Okay, what's up? Welcome back to the channel. This is the Prokon Geek, and in today's video we're now moving on to the design of our slabs in Sumo. So without wasting too much time, let's just get right into the big SUMO and get into the video. Okay, so remember, before we actually get started with Sumo or me showing you how to design your slab, please remember, if this is your first time coming to this channel, just hit the subscribe button. It's at the top of my channel or of your screen if you go to my homepage. And also, please, if this is not your first time, just subscribe. If you haven't subscribed, remember to leave a like and comment on the video before we proceed, as these are the things that help me to produce this content for you guys. So please subscribe, leave a comment, like the video, and let's get started. Okay, so to get started with Sumo, it's quite easy. All you have to do is open it up, obviously in your Prokon, but mine takes too long and there's so many things. But just click the button, then you'll be greeted with an interface. So the first thing that you want to do when you come to this interface is go to File. Then obviously you want to create a new file, then specify the working folder that you want. In this case, let's just put this, we're going to code this tutorial slab 1 with the 1 like this. So obviously if you want, you can change the path that you want to your folders to save in, but I am already saving in the folder that I want my slab to be in. So this is where you set your working folder. That's the first thing that you do when you're in Prokon. And then once it does that, it gives you a new main model. In this case, this one we just created, titled tutorial slab 1, and this is the first thing. All you have to do is now maximize the screen so that this is the thing that greets you on your screen. So this is step 1, ladies and gentlemen. Okay, now we need to go to step 2 after completing step 1. So this one requires us to go a little bit back to AutoCAD, because Sumo is it has a nice interface for us, but it can be a bit challenging to model what you want to model if you're a beginner. So as a beginner, the first thing that I want you to get comfortable with the software. So the first thing that we're going to do for step 2, we're actually going to create what you need to do is to create a shell of your slab. In this case, it is easy as just doing what I did here on the screen. So obviously you're going to go to where you have your layouts, and in this case, you know the slab we want to design is the first floor slab, as you can see indicated by the thick outline on one of your layouts for the first floor layout. So all you have to do is clean it up and then come up with a shell. Then once you're done, you have to copy all of this, excluding the dimensions, and then go to a new drawing that is clean, that does not have anything else. In this case, as you can see, it only has one layer as opposed to my tutorial layouts drawing, which has so many layers. So that is the difference. So you want to put this shell in a whole new interface that only has one layer and nothing else in the drawing. This is helpful as you don't want anything to mess up your drawing or to interact with Sumo. That is unnecessary. The only thing you want are the lines guiding you to where the edges of your slab are, where your beams are, and where your supports are. So this is what you want to do. And then you obviously want to rename this drawing to something that you will remember. In this case, I named it Sumo reference shell, and I saved it to my working folder. In this case, if you want to see it's saved as a drawing, I saved it under the folder slabs where I am working with. No, that's what you have to do and save it. So make sure the second step is you draw your shell in AutoCAD where you have your layouts, then transport it to a new drawing that does not have anything. All you have to do is new drawing, then use ACAD ISO as your drawing template. Then once you open that, paste your shell, rename the drawing to whatever you want, reference shell, and then you're good to go. So this is the second step that I wanted to tell you about. Okay, now we are moving to step 3, and what you have to do is go back to Sumo. Now, once you're in Sumo, the first step was to set your working folder. The second step was to create a shell. Now, the third step is to import the DWG and from its saved location. So all you have to do is go to File, then go the way to import, then go to DWG, import DWG file. In this case, we only have one DWG file, which is the Sumo reference shell. Click on it, click on open, then this is what happens. What you want it to be called, just leave the prefix default as it is, and then what you want to do, you want to specify what your DWG units were. In our case, our units, the ones that we were using, were millimeters. So then just click it OK. It knows the drawing was in millimeters, and the next step that it is going to do is now make sure it imports all your lines, and they are now in meters because Sumo works in meters. So this is the next step that you wanted to do. The next step is just to make it show up on the screen, and that's what we're going to move on to. Okay, so to make sure that your lines show up on the screen, this is the thing. Yes, we did import them, but they did not show up on the screen. This is one thing. This is a problem that most people do. I had just forgotten about this. The next thing that you want to do is just go back to where you had your Sumo shell open. Make sure you save it. Then you close it first before you import it. Next thing, now just repeat the process. Go to DWG, then click on Sumo reference, open it, specify that you're working in millimeters in DWG, and there, voila, there you go. As you can see on the screen, your line work is now on the screen. You can see it, and this is what we are going to start working with. This will be referenced as 2 meters. This is 6 meters, 555. Everything is now okay. So as you can see down in the tables, it imported 22 lines, 0 circular arcs, 0 circles, and you're good to go. And if you go to your groups, you now have a new group called Sumo reference shell, which is visible and its color is in black. Now let's go to the next step. So the next thing you want to do after your lines are now visible, you want to go to groups where we already went, and we now need to start creating our shells, groups, or whatever you want to call them. I call them shells for the next things we want to create for the slab, beam, loads, supports, and anything of importance to us. So the next thing we are going to do is now create a group. What I'm going to do is I'm going to call this the slabs. This is where our slabs will be. Then the next group, I'm going to call it the beams. This group is for the beams. And then the next one, I'm going to call it the loads. Let me separate them. I'm going to go with area loads. Right. Then we need another one. This one, I'll call it line loads. Okay. Then I also need a group for my supports. And let me see, what else do I have that I may need? Slabs, beams, area loads, line loads, and my supports. I think I am good to go. I do not see anything that will go. So the line loads, I could have called them the walls, but they're okay. We're okay with them like this. So I think these are the groups that you need. This is the next thing that you want to do. So after you're done showing up your lines, the next thing you want to do is create the groups. And this is what we have just done. Okay, now once you're done with your groups, the next thing that you want to do is import some materials so you can use these materials. So all you have to do is go to materials, then you want to click import, and then in this case, since we are going to have a reinforced concrete slab, let's go to concrete. Then we're going to choose, I think I remember from my notes, let us go to the notes and see. We're going to have beams and slabs. In this case, our beams will be 30 and our slabs will be 30. So this is okay with me. So what we're going to go is we only need one. Add grade 30 MPa. Add this and then click OK. And then once you do that, if you go to the materials tables as well, you have material 1. What we can say, we can call this grade 30 concrete. It's called grade 30 concrete. You can change the name if you want. What type? It's concrete, 30 MPa, grade 30 concrete. Then there's obviously, it comes with its E, self-calculated Poisson's ratio. The density is 25. Thermal expansion is given. And the color, I'll just put it to blue. Blue is okay, so we're going to go with blue. I don't need anything. So I think this is done. So that is the only thing that we need to do for this one. We need to import the material, and we have just imported the material. The next step that we now need to do is actually draw the slab. Okay, now since we are done importing the material, we have it on the screen. If you check where my mouse is, now the next step we need to do is actually draw up our slab. So you can zoom out. Then all you have to do is come to Home tab. then insert a structural slab, click on the slab. Then all you have to do is, this is why we imported the points for the DWG, so that we know where to snap. This is much more difficult if you want to do it in Sumo if you're a beginner, but I'll be making videos on Sumo much later on, so you can stay tuned in for that series. So all you have to do is, now you want to snap to this point, then you want to snap obviously to the edge, then you want to go all the way, snap to that point, snap to that point. Then you want to close it up, make sure you snap into the original point. Then once you're done, just click on accept, and there you go. There you have your slab has been constructed. Now the next thing is just to edit some properties of this slab. So just click on it, then go to your properties tab. What is its name? You can change this. You can say it's class slab. You can change it. Let's just make sure it's what we want. But I think slab 1 would have been good. Slab 1 would have been good. Just slab 1. We don't really need to change these things too much. The groups, where do you want it to be? You want it to be a slab, so put it to the slabs group. Then what color do you want? Blue is okay. For the opacity, I'm just going to change it to 50%. And as you change the opacity, see what happens. You can now see through the slab. Then the next thing, the thickness, we have a 200mm slab, so it's going to be 0.2 because this one deals in meters. Then for the mesh size, remember, you are not going to get a result unless you put a mesh on your slab. So the best value is either from 0.2 to 0.4. So I'm going to go to 0.3. Then what material do I want for this slab? I want it to be grade 30 concrete. And I think we're done. So that is it. We have just edited the properties of the slab. It's now set in stone. And now the next thing we need to do is add the beams. So that is the next step that we're going to do. So let's get to the next scene. Okay, so the next step that we want to do is add the beams. This is easy. I think you now know what we all have to do, and we already know where our beams are. So we're just going to click to beams. What type of beam do we want to add? In our case, we have monolithic beams, and they're different from just the beams. And also, I'll show you an advantage of adding monolithic beams. So you want to create monolithic beam. Where do you want it to start? Obviously, you want to snap to that point. Then I want it to end at that point. Once I've entered it, before I go, let me change the opacity to 50. Right, the section width, I want it to be 0.23. That is okay. Section depth, what do you want it to be? I think this beam, this beam was 300. This one, no, I don't think so. I know so. This beam was 300. The only beams which are 375 are the beam that is along this direction and also the middle beam in this direction. So those are the ones we're going to make 375. Right, and then start fixicity. The start fixicity, what you want to do is you want to make them pinned. Then end fixicity, you want to make it pinned as well. Then as for the material, you're going to go with grade 30 concrete. Segments is just going to have, in this case, I wanted to have one segment. That's the best thing. That's the other thing if you're creating monolithic beams. So if it was a different, what do you call this? This is a continuous monolithic beam. If it was a rectangular beam, it was going to be a different case. In the case that you were going to have to put 2 segments, but with monolithic beams, when you're in Sumo, you can just put 1 segment. As we did not separate the 2 segments, even though it's continuous. We just put it as 1 beam. So once we are done, I think everything is satisfactory and we are good to go. The next thing is to put the next beams. So all that, I'm just going to be now moving it fast as possible. So before we actually move on to adding the other beams, I just wanted us to get a feel of the beam that we added, so we can change up the view so that we see it from the front or from the top. Right, this is the top. If you want to see it from the left, this is from the left. If you want to see it from the front, but I wanted us to zoom on it into the front. So as you can see, this is one thing we need to talk about. As it placed the monolithic beam, what it did, it centered the centroid of this shape or the section to the same point as the centroid of the slab. But in our case, some of you may be asking, in real life, obviously our beam is flush with our slab and does not protrude over our slab. But in this case, our beam seems to be protruding over our slab. So is that important? Well, it really is not, to some extent, to a very great degree in Prokon, because what it does that's why I was saying that is the beauty of monolithic slabs. It already knows it's a monolithic slab, so it it conjuncts it into the design and takes care of it whilst it is designing. But if you want to be strict, what you can do is you can then go to your slab, right? To your beam, I mean. In this case, you can choose an offset. In this case, the best way to shift down the beam is going to be by an offset of 0.05. I'm sure by just looking at this, I'm sure, and there you go, it is 0.05. And as you can see, it now mimics the actual or the real life conditions that you see on the actual ground. So this is one thing I wanted us to talk about. But if you're still a beginner, don't worry, you can leave it at 0. It's not a problem, it's not a challenge. But if you want to be more strict and more, but you will see the results do not really change that much. It's a very, very small factor, which doesn't cater to factor if it's a very small structure. But obviously, if you're doing with a very huge structure where every small degree takes into account, these offsets will be very necessary for you to save. Still, because at huge projects, it's all about saving money and costs. Okay, now that we have talked about the offset and non-offset of the beam, we now need to add the other beams of our structure. So go back to home, isometric view, now zoom into our structure. The next thing you want to do is put your beams. Add the rest of the beams. They're going to be monolithic. Is everything okay? The offset is not, it's 0.05. Then the opacity is that, then 0.23. So it remembers your previous settings. I don't know why it chose the offset of negative, but it remembers your previous settings. So we got 0.23. Section depth is 300. I'm okay with that. Pinned, grade 30 concrete. That is okay. So we're going to snap to that corner, and then we're going to get with this whole beam all the way. Then we snap to that point. Then we got a beam. Then if we want, let's put our other beam. Snap to that point. Snap to this point as well. Then we're going to put another beam. Snap from that point. Snap to that point. So we have our beam, and then this other beam as well is also. Where's the snap? There we go. You have a nice snap. Then we have this beam. Let's see, let's zoom in so that we snap to the correct point, because you see, if you snap to a very wrong point, the structure will tell you there is an error when you're trying to run it now later on. So now our beams are about to change, so we can just get out of this and then choose beams again. Then monolithic beams. This time we want to change the depth, the section depth. This becomes 375. So we're gonna put it there, and we're gonna go there. There we have our beam, but this one I think I should have made it orange. So let me just get out of the tab, try to change. Let's make it a different color. This one we can make it green, show that it's a different type of beam. Then in this case, let's go back with monolithic beams. Let's make sure the color is green, but then the depth is now 375. So you're gonna snap to that point, and then snap to that point. All right, there you have it, ladies and gentlemen. You have modeled your slab and your monolithic beams in Sumo. So this is it. If you want to say it from the front, this is it from the front. All right, and then if you want to see it from the top, this is it from the top, where you have your beams going all there in that direction. And what else do you need? What else do you need? What else do you need? Let me see. That is it. That is okay. You're good to go. So also you need to remember, I am using 2.6 for my program. So in 3.1, these edge differences were fixed. They added a fixture for that, because if you see, we only have an offset for the y direction. We did not have an offset for the, what do you call this, the x direction. So that is something they fixed in 3.1. I haven't upgraded. I don't have the money to upgrade, so please don't judge me on that. So this is some of the things. So don't worry about whether these edges are not, it is in real life. I'm still using 2.6. I hope to use 3.1 soon, and it's much better. So many glitches have been fixed, but then that's a bridge we will cross when we get there. But this is what we wanted to do. We wanted to add our beams, and we have done that. The next step is now to add our supports. Okay, so the next step we need to do is we need to add our supports, and as you already know, we have columns for our supports. So some of you may be thinking, okay, this is the time we put the columns, but no, this is not the time. So the issue is we are not modeling the entire building. What we are doing is we are trying to design and analyze the slab. So in this case, the most important thing that we added here was the slab shell. Then the beams, the reason why we added the beams as well is because these beams add a factor of rigidity and separation to our slab bay, thus separating them into different panels. That is why they are also very important. But when it comes to the columns, just remember your columns are your supports. So it's as easy as just adding your support. So this is what we're going to do. We are going to approximate our columns to pinned supports. Remember, as we were designing our columns, we designed them as pinned supports. So we're not going to be adding the columns. This is why it is good to design things in halves. You can do the entire structure from top to bottom, but sometimes when you just separate them, it's easier, and it also makes the analysis much better for you, and also it reduces the chances of you having errors or having to run the iteration of the program so many times. So the next step, I just wanted to talk about that. Now let's move on to adding our supports. Okay, now we are adding our supports, so it's as easy as going to, there you go, you get supports, add supports, right? What you're going to do, you're going to add a single support because you have a single column. So you're going to add your support to where you already know where our supports are, where your columns are supposed to be weighted. Okay, there it goes. So we're just going to put the support number 1 there. So this is what we're going to do. Before we go, this is what we need to do. We need to make sure that this group is under supports. We should have done this before we actually added this. So for the color, I'm just going to put them to orange. And then the type, yes, it is a rigid support. Rigid support, yes, it is a rigid support. Then what are we going to do? The next thing that we want, rotation is free, yes, because it is pinned. It's a pinned support. Then the next thing we're done, so make it free. Then also make this rigid, and supports. This is what we wanted to change. Now we can actually start putting the supports everywhere else. We're going to change the last one because we were supposed to make these parameters or key in these parameters the first thing before we actually put the first support. So we're putting the supports where the columns are. There you go. All right, put your support. There you go. Nice and easy, baby. Nice and easy. All right, nice and easy. There you go. Escape to get out of the command. Go to this one. Make sure that it is orange. Rigid. Free. That is good. Point support group, make sure it's under supports, and you're good. So that is one thing that you want to do. And I think I did not add these beams to groups, so that is the next thing that we need to do. Okay, so the next thing that we wanted to do before we actually go to or finish up on this is to make sure, or add our loads, is to make sure all of our beams are in the beam group. So this one was not in the beams group. Is there anything else that I needed to add? No, it's okay. So that beam is now in the beam groups. Then escape, select the other one. Put it in the beams group. Escape, select the other one, group, put it in beams. All right, then this one, put it in beams as well. You're going one by one. Let's make sure this one, yes, it's in beams. This one, yes, it's in beams. This one, yes, it's in beams. This one, it is not, so make sure it's in beams as well. Then the green one, is it? No, it is not, so make sure it is in beams as well. The green one this time, this one is in beams. Make sure it is in beams. Want to make sure it's in beams. Then the first one, I don't know how did I miss this. We're sure it's in beams. I just change the opacity to 50 as well so that it matches. So all of our beams are now. So if you want to verify if they're in beams, what we can do is go to the groups and just make this invisible, and there you see it's actually there. So this doesn't remove your beams, it just makes them visible or invisible. So in this case, our beams are now in one group, so we can turn them off when we want and when we don't want. Similar for the slabs, if you want to remove the slabs, just have the beams. You can, this is what you can see, as you can see. So that's the cool thing of what do you call this? Sumo. It helps you to turn things off or on whenever you need it. Now the next step that we need to do after putting your supports, we now need to put the loads. Okay, now we need to put our loads into Sumo, and the first thing that we need to do is we need to put in what we call the load cases first. So just go down where you see where you have the groups, all those tabs, go to load cases, click new load, add load case 1. Obviously, I think you know what the load case is, what I mean. So we have load case 1. This is going to be the dead load, and this is the one that we will have self weight. So you want to tick self weight, and then you're going to have load case 2, which is going to be the live load. So dead load and live load, just remember this is how it goes. There you go. And the live load is not going to have the weight case, so it is good and we're good to go. That is the first thing that you want to do. Then the next thing that you want to do is you want to go to load combinations. Combination 1. All right, which load cases do you want? The notes, this one is going to be dead load only. Right, so what load case do you want it to have? I want it to have load case 1 only, and the load case factor for that, if it is dead load only, SABS is 1.2, and serviceability limit state it's 1, so it's 1.2 and 1, so that is good to go. We're good. Then the next thing that we want to do, let me see. The next thing that we're gonna do, what is the next thing that we want to do? What is the next thing? The next thing is to add combination 2, which is going to be DL plus live load. As you remember, I do it for the worst case scenarios only. So under this case, what you want to do is when you go to load case combination 1, it shows you which load cases are in the combination. In this case, we only have the load case 1, which is the dead load only, and in this case we have combination 2, which is going to be DL plus LL. Now we're going to add our load cases. We're going to have LC1, and then we're going to have LC2, which is the live load. So for the live load, this is going to be 1.6. okay, then obviously it's going to be 1 there. Sorry, I don't know what is happening there. Okay, wait, load case 1. Woo, something is changing. This is supposed to be load case 2, this is supposed to be load case 1. All right, so no, this is supposed to be load case 2, then this is supposed to be load case 1. Okay, so with load case 2 it's 1.6 and 1, then it's for load case 1, which is the dead load only, you want it to be 1.2. so please take care, these abbreviations can be too confusing at times, so remember which one you code dead load and which one you code the live load. So load case 1, by default, I like to call it the dead load, and load case 2 the live load. Once you have done this, the next thing now is to actually put the loads onto your slab graphically, as you have managed to put your load cases and your combinations into play. So let's do that. Okay, so the next thing that we need to do is actually input the loads, and to do that, it's now easy. It's just as simple as going to where your loads are. But first things first, let's turn off our beams, turn off our supports, and then we get started. So just go to area load, select your area load, then you want to put this, which group do you want this to be? I want it to be in area loads. Okay, and the damage, the figure O, the intensity of the load, I want it to be 5 kilonewtons per square meter. So yes, -5 is okay. Then which direction you want it to be in the global Y? The global Y, remember, is this one. It's shown by the blue arrow is for your global Y, so you're good to go. If you say -5, it means that it's a load that is going down. So all you have to do is start snapping. Snap, 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 snap. There we go, snap, and then just click accept, and there you see it, ladies and gentlemen. Entering your loads in Sumo is easy as cutting butter with a knife. Yes, it's easy. When you're entering your loads in Sumo, it's quite easy. As you can see, it also gives us a graphical representation of what your load will look like, either from the front, from the left, from the top. Obviously you won't see it from the top, but in isometric mode, but you can see it. It looks nice, and there is your load. The next thing we now need to do after inputting your area loads is to put in your line loads. And the first step in doing that before we actually proceed is to just turn off your area loads. And now let's get started. Okay, so as you already know, the line loads represent the load coming in from our walls, the load that is coming in from our walls. So I think the first step that we need to do is now documents, just go to Red Geek, graphics, story, double story, then MathCAD sheets. What is the load from the walls? We just need to visualize what the value from this loads is. So MathCAD is starting out, e.t.c MathCAD. It's a very cool software that I think all of you need to download. Here's a free trial, and if you want the full version, you can pay, subscribe. If you don't have money, I think you can use the internet to find whatever you need to do. But I by no means endorse piracy. I am not for piracy, so please, YouTube, do not penalize me. I am not for piracy. Yes, so as we can proceed, the load is going to be 15.87. That is okay. So the next thing that you want to do, obviously you want to go back to Prokon, and now you need to put in what we call the line loads. And our line loads, if you remember, they're going to be for the walls. So they're going to be over this portion, this portion, this portion, and this portion, and then also this portion. So this is what we're going to do. Where do we have our line loads? What value do we want this line load to be? We want it to be negative 15.87. If you're feeling too conservative, you can go with negative 16. I'm feeling conservative. There's no need for me to put 5.87. Just put it to negative 16. Then what do you want to do? We want to put it to load case 2. So yeah, that's good. Then as for the groups, we want to put it to line loads. So yeah, we're good. So we're going to call this wall. Let's just call it wall 1. So wall 1 is going to go all the way from there to there. And there you have wall 1. Now we need to put in wall 2. This time let's just put it to 2 so that it's good. Then there you go. You have wall 2. Then now we need to put in wall 3. So let's make sure we snap in wall 3 all the way to there. Right. And then now you have wall 4. So wall 4, we're going to snap from this position, going all the way to this position. Right, and then the next thing we need is wall 5. So for wall 5, you're going to snap from there all the way to that position, and we're good to go. So that is how you provide the line loads. As you can see, I'm making this simple. It is quite simple. There you have your line loads. If you want, you can turn them on. If you want, you can put the area loads on and the line loads on, or you can just put the line loads, and there you go. You can visualize whatever you want on, off. It's okay. The next thing, after putting in your line loads, we need to evaluate if we have everything that we need. Okay, so the next step is to evaluate if we actually put in everything that we need. So let's put everything back on. The beams, supports, yeah, everything is back on. So yes, I can see I have my beams. Wherever I need beams, I have beams. And then wherever I need supports, I have supports. These ones are representing our columns. And then wherever I needed my loads, I have an area load throughout the entire slab. Then I have these line loads. Oh, okay. One thing I had forgotten. But no, I haven't forgotten anything. Because the 5 is in gymnasia, and also it's catering for the finishes as well. So we don't have to worry about that. Then the self weight, which is the dead load, will be contributed to the final, what you call this? The final calculation, so we don't need to worry about it. And the reason also why I picked 5 is because if you really look at the BS, it says 4 for places that are suspect to crowding, but then I went with 5 because this will also cater for, if you see when we were designing all of our beams as well, we were saying 25% of the live load will remain permanent, so that will also cater for the finishes and everything. So 5 is already sort of an overkill for the slab, so 5 will cater for the finishes. Don't worry about it. So 5 and the self weight is okay. We don't even have to worry about it. Everything else will be catered for in what do you call this, in the self-weight case. So we're good to go. 5 is good enough for us. None of our finishes will be providing too much of a weight to anything of this, so 5 is okay. Just remember that. Okay, once you are done checking whether everything is okay and you've molded your structure nicely as we have done, the next thing we want to do is actually analyze and then proceed to design the slab. So to do that, the first thing that you want to do, just turn off your beams, your line area loads and your line loads. Then this will enable you to select the slab nicely. Then proceed to click mesh. Then it starts meshing. Then once it is done, just turn everything back on if you want. If you don't want, it's okay as well. So after it has meshed, the next thing that you want to do is now go to analysis. Check your model. Do you want to save changes to tutorial slab 1? Click yes. Then it does whatever it does. Does an assembly, does an audit, matrix assembly. It solves it. There you go. So it has checked your model and your model is good. There are no errors. Then the next thing you want to do is click on solve. Let it solve, let it solve, let it solve. Let it solve. Let it solve. Let it solve. It's Easter, so we gotta go a little bit preacher. Let the preacher solve. Yes, we're good. We have solved our model. This is it. Once you see this, then it tells you, it gives you a detailed view. All you now need to do is your model has been solved. Go to results and click on main results. And there you go. You have your solved model. And the first thing that it shows you is the deflections. And as you can see, if you hover around at every node, it gives you the information of the deflections. As you can see, we have 2, 1, e to the power of whatever. So these are the deflections that you want. So as you can see, but now let's go to how you interpret these results and how you can actually view them. So what we just did, we analyzed, we solved it, and now next let's interpret the results. Okay, now we need to see how we interpret our results when we have the final thing or when we open the main results on the screen. So obviously the first thing that greets you, in our case, it was our slab. We had turned some things off, but our slab is the main thing that we are interested in. So as you can see, the first thing that you go to the properties. This is where you can now visualize your results. By default, you're going to have, I think, the worst case load combination given, and in this case it was C2, and then you always want to leave original ticked. Then for the intervals, this is, you choose how many intervals you want, any contours. Contours will be giving you, I think you already know, if you remember from geography, contours give you the various ranges of your loads, results, or whatever it is, whether it's elevation, intensity, rainfall. In this case, it will be for your loads with deflections and anything. So by default, it gives you 7 intervals, and I just leave it at 7, which is okay. The next thing, you choose whether you want them to be filled by color or intensity, or you want them to be transparent. I prefer color, gives us a nice thing, and you're going to see this in the next thing. So by default, you're going to have your deflection enabled. This is what enables you to see or visualize the slab. So make sure you have it enabled before you proceed. So yes, let me just show you the contours. So this is when you have it enabled. This is what is on the screen. Then when you click contours and then you click it, there you're now having what are you visualizing? What you're visualizing right now is the deflection. So you have your 7 intervals, and the maximum deflection is always found at the bottom. In this case, it's 7.859, which is less than 20 millimeters. So we're good to go. So as you can also, this is the beauty of contours. It shows you where you have the minimum and where you have the most deflection. In this case, it shows you the worst affected areas where your slab is deflecting the most. And as we can see, it deflects the most in between between the 6 meter panel width. That is where it deflects the most, and at the edges, that's where also you have the most deflection, which is in orange. Now the next thing that you want, you can now turn this off for deflection, so they're off. And the next thing, you can just close this as well. Next thing, you can open up for the beam forces. So if you want, you can this enables you to visualize all the forces that are occurring in your beams. and there it shows you. If you want, you can zoom in so that you can get an idea of the values at every point, in every point that you're getting. So if you want, you can zoom in even more or less. So it's up to you for this, but then we don't want to design our beams, we want to design our slabs, which is why we came here. So for the beams, we'll look at it in another step, but then right now we want to visualize our beams and our slabs, I mean, and this is the most important part. So we're not going to worry about the beam axial forces. Then obviously, if you want the shear, it will show you the shear in each and every one of your beams and your slabs. And we already did this when we were designing for our beams using the continuous beam module. So you can visualize where the values are. This, I think the maximum shear that you're getting is about 121. I'm not sure what the values were when we designed our values, but I think they're along the same line. So this is how you can visualize the shear which is occurring in each one of your beams. If you want to zone it in, you can zone it in for clear representation. And if you want in X as well. But then the most important thing that we need to look at, you know, you can visualize anything that you want, the moment in the Y as well. Let me just show you, right? And also if you want the moment in the X, there you see, you go, you see it, the maximum moments, and you know, it's okay, you can see it, you can visualize, and then you can design for this. But we are not going to be designing for this. And if you can remember, I think the maximum moment we had was about 200 when we were 100 something when we were designing with the other thing, and as you can see, we're already at 107 for this. But now we're not going to worry about this being forces. The most important thing that we need to worry about are our shell forces, which are the slab. And now let's start looking at these ones. Okay, so now we are looking at the shell forces, which are the slab forces, or the reactions, the analysis, the results for the slab. So the first thing, what type of representation do you want it to show? Just make sure you're using the contours. The contours are the best thing. They enable you to see the best, or they give you the best representation of your forces. Then also make sure direction is ticked. This is important so that when you're able to visualize the direction in which your steel will be going, that is your reinforcement steel, it will show you where your steel needs to be laid or how your steel needs to be laid. The multiplier, just make sure it's 1. Then we need to start dealing with our slab. So SX, this one is all for shear. This is where you can visualize the shear that you want, but we don't really need to visualize, you know, the shell stresses that we need. The most important thing when it comes to visualizing for your slab, let me just show you. It's either you want the moment that is at the top, right? Your moments that you have, as you can see, if you go to the kilonewtons per meter, shows you the maximum moment is 85.9, shows you that it's mostly a hogging moment at your supports. You remember, this is where we have our pinned supports, which are our columns. Then also, if you want it in the bottom as well, shows you where you have the maximum moment. But when you're designing for a slab, the most important results that you want are ASX prime, these last 4 boxes. Why? Because these ones represent, let me just take the first one. So this gives you the reinforcement in the X direction that you need at the top. So which direction is the X? This is the X direction. Wherever you see these lines popping up and jotting, if you look at them, if you zoom in close, you can see those lines are laid in the direction. So that is the direction which you need to reinforce for the steel. So this is the steel that you'll be laying in this direction where my mouse is moving. That is the steel that is parallel to the longer side of your slab. So the maximum that you're going to need is 1424.78 square millimeters per meter, and you will need this mostly at your supports. In the middle, you may not even need it at some points where it will just be less than 200 or 0. So this one also gives you an idea of where you need the most steel and where you need the least steel. So these are the results that you get when you do Sumo. So this is the beauty of Sumo. This is what you then use to transfer to pads so that you can detail your slab, which this is what we are going to be using when we are detailing our slab drawing. So if you want, you can get a screenshot for some base. Sometimes you don't need to get a screenshot. You can always output the calculation sheets, but a screenshot is always beautiful, especially if your Sumo drags, so that you remember the correct values that you need for your slab. Then the next thing is obviously the bottom steel in the X direction as well. This shows you, as you can now see, but now the difference is the maximum moment decreases. It's 859.581, and as usual, you need most of your steel closer to your supports and the edges, and these are the hard hit. These are the most hard hit edges, the way you need the most steel. Then if you want to go for the Y, all you have to do is ASY at the top. So in this case, in the Y direction, this is the steel that is parallel to the shorter side, to the shorter span of the bay, or you can say that is perpendicular to the longer side of the slab. So this is where you need the most steel, where you need 1766.663, mostly at your supports and at the, what do you call this? This is where you have your edges, or the edges. And the reason why you have most of the load and the supports as well, the whole game moment, is because you have a wall on top and you have 5 kilonewtons, but then when you look at it, at the other side there is no load, so you have a wall and then you have the aerial load at this point. That is why your moments are also larger, because the load that is being experienced at that point is quite huge. And then for the bottom in the Y as well, they are the values, and you have 1077.388. This also quite ties up. It goes mostly to the center and then at the edges. So this is the representation of where you need most of your steel. But when it comes to detailing, as I usually say, the most important thing that you need to note are the maximum values when it comes to detailing before we actually now. But we have analyzed and we have designed our slab. The most important thing now is we know the steel that we want. We know the maximum steel that is needed. The next thing will be detailing, and that is what we will now need to move on to. So let me just wrap up some of the notes and see what we're going to talk about. Okay, so as I have been talking, I have been showing you how to interpret the results of in Prokon in Sumo, and in particular case, since you're a beginner, we wanted to focus on our slab so that you understand the most important things that you need. And I told you there's 4 last bars or check boxes are what you need to dwell on for now, because the reason or the objective when you are designing your slabs is you need to see the reinforcement, and this is where the reinforcement comes in from. Okay, so this is the gist of modeling in Sumo. This was just an introductory video, but straight to the point. I was showing you everything in steps so that you can follow along with me. Sumo takes a bit of time. Sumo and frame, actually, Sumo and frame take a bit of time to clearly understand and grasp. So what I'm going to do is next time we're going to start afresh, get an introduction to Sumo, every concept that is in Sumo, how each thing is interpreted. So if you want a video series on Sumo where I start by teaching you from the grid reference axes, load cases, and everything, where you want it in depth, please leave a like on the video, leave a comment to affirm that you definitely do need those videos, as I may be making a video that you guys do not even want to see. So if you want a video or a series that is specifically dedicated to Sumo, please leave as many likes as in this video. Please, if I'll just put it to this, if we get 50 likes on this video, we are definitely doing that series as fast as possible. Otherwise, I'm still doing the double story series of videos, because those are the videos most people demanded or vouched for. So in this case, I've gone through Sumo. I think you now have an idea of Sumo. We have designed our slab. If you want to save, don't even worry about it. All you have to do is just save this, right? And it will be there for you. Whatever you want, it will remain there for you. So your calculation sheets. This is a bit. Sumo can be a bit funny sometimes, so this is why the main reason, like I told you, mine crashes and mine drags as well, because it's an earlier version. So I'll try and cover all of those tricks that happen. So the best thing that I usually do is I leave my project in this condition, so that all I have to do when I'm now detailing it, all I have to do is come back to Sumo, see the shell forces, see the reinforcement, and then detail it accordingly to the design that we have made in Sumo. So I would like to thank you very much for tuning in this video. It's been very long, but thank you very much. If this is your first time, please just subscribe to the channel. If it is not your first time, please leave a comment, please leave a like on the video. This is how I continue to make amazing content for you guys. And thank you very much. If the voices have changed, the energy has gone a bit low because the video has been long, but thank you very much, and until next time. I think now we are moving to detailing our slabs. I don't think we really need to design the roof. That is mostly done by roofing contractors. They know what they do, plus it's a timber roof. Basic carpenters can also just do it for anyone. But what I'll do is I'll try, after detailing, I'll try and make a video where we design the roof in Prokon, although it's not quite necessary, and then detail it as well. So I think we're done. We have covered the foundations, the slabs, the beams, and the columns. And yes, we still need to design the columns for the second floor and the eaves beam. So yes, we can do that. But now I've covered the essential parts. You understand what it is. The next thing, I think we can also just go to detailing it, and we will be done. So thank you very much for tuning in. Subscribe to the channel, and until next time, peace.